And hello everyone, welcome back to a new video. So in this video we're going to be covering variables and data types, which is a very important topic for basically any programming language, so make sure to stay tuned. So what is a data type? Now a data type is basically a type that you can store inside of something. For example, let me just make a nice comment here. A char would be a single character because that's a character, a char. So S is a char, A is a char. 1 is also a char if it's inside of single quotes. Take note, all chars will be inside of single quotes. Not double quotes, but single quotes. This is very specific. So this one here, that would be a char. But take note, this one here, that's an integer. And this one here, that is a float. Now, you might be getting confused, like what's an integer, what's a float? What's all of this? Okay, so we covered that a char is basically a single character. It's like basically A, B, C, D, or 1, 2, 3 in single quotes here. And there can only be one between these single quotes. You cannot add like A, B here. That is no longer a char, so that will be invalid to type. So only A, or only B, or only 1 between these. An integer is a whole number, which means 1, 2, 3, -5, 0, -10, 66, whatever. That's an integer. It's a whole number, and you can it's just a normal number, like you count. A float is the same as an integer. However, it is not a whole number necessarily. For example, you can get 1.4. That's a float because it has a 0.4 at the end. Anything that has this 1 point, after that we have a float. So 3.14159, that is pi. Pi is considered a float or a double. You'll see me in this course use those two words interchangeably, but float and double are kind of the same thing, where double is just like a bit bigger than float, and we'll get into that in a second. So this right here, that's a char character. These right here, they're not chars, they are integers or int, and they can also be seen as whole numbers. Take note, they do not have single or double quotes, they're just numbers. And that's a float or a double, or basically a not whole number. So yeah, those are some of the most basic ones. And also we have to cover booleans. So booleans are like yes or no. So if someone asks you, are you older than 18, you answer with yes or no. And in computer language, yes and no are determined by true and false, where true will be yes and false will be no. So let's say you ask the user, are you older than 18? If they answer yes, then that will return true. If they answer no, then that will return false. And you can use this to add logic to your program, and we'll get into that in a different video, but it's kind of out of scope for this one. And you also have strings, which is basically like a bunch of chars added together, but they are instead of double quotes, because strings are double quotes. As you can see here, they are also in double quotes. And I remember, if I was right, on the beginning of the video or on the beginning of the series, I said always use double quotes here. That this shouldn't be single quotes or any other quotes, they should be double quotes. That is because this right here, that's a string. It's a whole word. A string can be basically anything here. That's it. It's a string. If it's inside of double quotes, it's a string. Okay, now let's cover them a little bit deeper, just so we can get kind of the idea of what they do. Now, we won't really be covering the sizes of these, because a lot of times you do cover the sizes, but I believe that's kind of out of the scope of this course. But if you ever want to know the size of a type, of a data type, you can just say size of here inside of cout, and let's pass an int. If we were to run this, then we get 4. That means an int requires 4 bytes of memory in order to be used. If you're trying to program something that has to meet like specific requirements for speed and stuff like that, this can be very useful, because then you can kind of measure how much RAM you should be, or how much RAM you're going to use if you try and use this data type or this data type and whatnot. I'm not going to cover most of them because I didn't feel it's necessary for this video, because it's kind of a lot to take in. But anyways, if you do want to know, chars are 1 byte, integers are 4 bytes, as you can see there. Floats are also 4 bytes, but doubles are 8 bytes because they can store more data than floats. So a float can, let's say, only store about 12 characters after the dot. I don't know if that's true, I'm just guessing here. But a double can store 24, for example, because it can keep double the amount. That's why it's called a double. Now let's actually get into using these. So to use them, I want to talk about variables. Now variables are basically containers. If you think of a variable, then you should think of just a placeholder for something. So let's say we get the name of the user, so the user name, right? We get that username, and let's say it's Nick, for example. Now it's either we have to remember it's Nick, and everywhere inside of the code we have to make it Nick, or we can store it inside of a variable, which it just contains it. That variable is just like another word for this right here, that you can use all over the place. For example, let's actually create a little story here. Alright, so here we have a little story. Let's just increase this. Okay. Now here we're saying, my name is Nick and I am 24 years old. Tomorrow I'll be 25 years old. I want to change my name from Nick to Jack. My new name is Jack and I'm 25 years old. Now, let's say this is a story of 30,000 lines of code, right? So you have 30,000 lines like this. Now, you want to change this name, because you now want to change the name of the main character, Nick, to, let's say, Mitch or something. And now, once we did it within a second, if you had a story that is, let's say, 5,000 lines of code, then you have to go and change it individually, and that's going to be a lot of effort. That's where variables comes in. We can store this inside of a variable. So let's create a variable. So I'm going to create a string here, and to create a string, you just say std : string. This string right here can keep text, anything inside of double quotes. And take note, I'm not using namespace std, and actually I want to remove this using that, and I'm going to go here and add our std here as well. There we go. So I'm not using namespace std, but if you were using namespace std, you could probably remove this. But then I'm going to say equal here, and instead of double quotes, I'm going to put something here. So let's say the main character's name is Nick, and at the end I'm going to add a semicolon. So cool, we created a string, but how do we access this string? We access the string by giving it a name. So in this case, I can say main character name. Of course, you don't have to make it so long. In fact, we can just say MC name for main character name. That will also work perfectly fine. You can put basically anything here, as long as it's not something that is not normal. For example, exclamation mark. I don't think that is allowed. It might be. No, it's not. As you can see, there's a little squiggly line underneath it. But you can use underscores, and that's about all you'll need. You don't have to use anything other than normal text and underscores. And I don't recommend you do use anything other than normal text and underscores. And also this here is called camel case. Camel case is basically when one does this. My name. That's camel case. So this right there, that's capital case. But you also get a styling of variables that's like this, my name. So you can also do that if you want, but never mix them like this, my underscore and capital name. Don't do that. That's just disgusting. So either go with underscores or with camel case. I like to go camel case with C++, but in other languages like Python and in Lua, I like to use underscores. So it's up to personal preference. But once you have done that, now you can use this. So this Nick here, let's add some quotation marks here to split this string. And now we can go here and we can say MC name. There we go. Now this main character name will be here. If we were to run this, then my name is Nick. Because this right here is just a placeholder. Basically, what's actually being said here, but we use this placeholder, but what's actually being said here is this. That's what's actually there. But we use this to reference that. And here as well, we can change that Nick to MC name. And there we go. Now Nick is there as well. Now let's see what we get if we run this. Hello, or just hello. My name is Nick and I'm 24 years old. Skip that. I want to change my name from Nick to Jack. Now that's very nice. But what about the age though? Because here we use 24, 25, 25. Well, we can declare an integer variable then. We don't have to use std. We can just say int here. And we can call this age. I'm going to call age, or I'm going to make age equal to 24. Now, this age can be referenced anywhere here, so I can go whoop and just say age. And take note, yet again, this is the same as saying this, but now we're referencing it from here. And you'll see how useful it can be in a second. And these are 25, so that is interesting. I'm going to show you how to work with that in a second. But if we were to run this, as you can see, my name is Nick and I'm 24 years old. Okay, neat. Now, let's say halfway through the story, we decide, okay, wait, I don't actually want the name of the main character to be Nick. I want it to be Caleb, for example. Save that, run the program, and here, my name is Caleb. I want to change my name from Caleb. So by just changing one line of code here, we changed everything in the story, or not everything, but we changed the main character's name. So that's pretty neat. Now, how will we go about changing that here? Well, this age, we can actually just say here, like that. We can say age plus 1. Because 24 plus 1, that is 25. So if I run this, we get tomorrow I'll be 25, and here he said 24. So you can use plus to add these together. We'll be covering math operators later, but you can use plus to do this. The same here, we can copy this, and here where that 25 is, we can just do this, and boom, there we go. Now age is basically changeable everywhere. So here we have our 24, 25, and 25. Now if I were to change this to 30, the code will dynamically change with it. So I'm 30 years old, I'm 31, I'm 31. So I only had to change one line of code, but it changed everything else with it. But the thing is, you don't always want to change it like this. So for example, with this string here, let's go here to where it says I want to change my name to Jack. Now let's say here in the middle of the story, you want to change the name to Jack, because that's what it's being changed to, and now the main character's name should be Jack and not Caleb. Then we can say MC name is equal to Jack. Don't forget your semicolons. Now we have changed this variable. This MC name is no longer Caleb, it's Jack. And now here we can still use MC name. MC name. So if I were to run this, as you can see, my new name is Jack, and we used MC name. So you can change these later as well. So this age plus 1, you can change it here as well. So we can just say age is equal to age plus 1. And this will change the age to its current value, so 30 plus 1, which will be 31. So now we can just say age instead of age plus 1. So we just cleaned up the code. And take note, these spaces don't really matter, but I'm just using them to make it a bit clearer. Maybe you run this. Then there we go. The story still works, but we learned how to use variables and how to change them in the middle of the code. Take note, this age variable here is permanently changed, which means until we change it again, it will forever be this. So just take that as note. The same here. So if we were to move MC name up here, then this MC name would change as well. Okay, so that was just an example. Now let's actually talk about the other things we can use. So here we can talk about things like, let's talk about char. So char is just char, and let's say letter here, A, that's a char. Simple as that. Next up, we have a boolean, so let's go bool, and let's say old, so if someone is old, and we can make that true. Or if you wanted to, we can make this false. I will show you how to work with booleans later, but yeah, and take note of this char here before I forget. Single quotes, not double quotes. Double quotes are for strings, single quotes are for chars. And then we have our int, and then we can also add a float here. So float, and let's say num for number is equal to 3.14159. We can of course also use a double, so let's go double. And we can make this x. And now we can add more values here. I don't know what's after now, so I'm just gonna whoops. Okay, so I'm just gonna add some random things here. So yeah. But take note, this char here, this can hold more than just letters. For example, if we add another char here, we can actually say number. I can make this 97. The reason is because 97 is the letter A in ASCII. So if I were to std, or I'm just going to cout here, and I were to put number here, let's see what we get. We get a lowercase a. The reason is because this 97 in ASCII is a lowercase a. And that means 98, that is a lowercase b. Let me just remove that. So if we were to run this again, then we'd get a lowercase b. So that is why this can also hold some numbers, but take note, if it's not an ASCII value, then it probably cannot be stored inside of here. You can also declare variables multiple times, or before you actually initialize them. So let's say int x and y. You can put them here. You don't have to put anything inside of them. Or you could just say int x. That works perfectly fine, but I'm just showing you can put multiple on one line by doing that, adding a comma. But let's say we just have one. And we can say x is equal to 10. You can do this. It's perfectly fine. And we can even go int y is equal to 9. And then we can cout x plus y. If you run this, then we'll get 19. So you can declare variables and initialize them on two different lines if you wanted to. There are more things that I can teach you, but the last thing I'm going to cover is unsigned. So an unsigned number basically means it cannot be less than 0. So if I say unsigned int, this means this integer cannot go below 0. So it can be like 1, 2, 3, whatnot. And if you just see out this again, and just put x here, if we run this, then we'd still get 2. But take note, if I go -1 here, it will not give me -1. It will give me the highest value it can get. So this is where the difference basically comes in. An integer, a normal integer, that can go below 1 or below 0. The reason is, you can get with normal integer, you can get half of this. So you can go half the way underneath this. So if we were to just take this, and just go like this and divide it by 2, a normal integer can basically cover this, right? But an unsigned integer can cover this. So this is the difference. While a normal integer can go into the negatives, it can only go about half as much as this one can. So you can use an unsigned integer if you know your value will never go under 0, and you know you'll need to use a massive amount, like a massive number, then you can use unsigned. And yeah, you can also use unsigned with floats and stuff like that. And yeah, that's about all I wanted to tell you for today. And I will see you all again in the next tutorial, where we'll be covering a few simpler topics.